Okay, good evening, members.
Good evening.
Good evening.
So, we are going to cover group 16, unique properties. So, group 16, we can also call them oxygen family. If you like, you can call them oxygen family. So, group 15, we said, can also be called nitrogen family. So, group 16, we have oxygen, we have sulfur, we have selenium, and then we have tellurium, and then finally we have polonium. So those are the members of oxygen family. So we are going to cover metallic character, electron configuration, and then we are going to see some other properties. So on metallic character, we are going to talk to say that increases down the group. Metallic character increases down the group. And then oxygen and sulfur. Oxygen and sulfur are nonmetals. Oxygen and sulfur are nonmetals, while selenium and tellurium, they show weak properties of nonmetals. Is that okay?
Yes.
So next we want to talk about electron configuration. So these elements need 2 electrons to complete their octet state and attain a stable noble gas configuration. Hence, this element tend to gain by forming that type of configuration. So there is something here we can note. That electronegativity of oxygen is very high, and that is why it shows oxidation state of -2 and forms ionic oxides with most metals. That one is for oxygen. So, and then there are few exemptions where oxidation state of oxygen is -1 and +2. So, for instance, we have hydrogen peroxide and then we have iron 2 oxide. So, in this case, the oxidation state of oxygen is -1 and here it is +2. So, polonium does not show any negative oxidation state. That is polonium. And then you have sulfur. Selenium and tellurium are able to show +4 oxidation state and +6 respectively, due to availability of d vacant orbitals. The d vacant orbitals we can remember as p, d, m. So we're talking about that one, the d vacant orbital. So, and a further excitation of ns electron that goes to the d orbital. So we have said the positive oxidation 4 is observed when one of the p electrons get excited to vacant d orbital. So when electron is excited into here, it shows +4. That one we are talking about polonium. And then when d orbital is further excited, the ns electron goes to the vacant d orbital, giving a positive oxidation of +6. So it possesses +4 and +6. So the same way with oxygen. So let's see something small on oxygen. Oxygen, it exists as 2 nonmetals. So oxygen exists as 2 nanometers. That one is this one and this one. So this one is oxygen atom. This one is ozone. Okay, so it exists as diatomic oxygen and triatomic oxygen. So what is the difference between the two? The first one, oxygen, is a stable diatomic molecule. Liquid one is pale blue, while solid one is blue. This one now. While ozone is triatomic. So triatomic allotrope of oxygen. It is dark blue gas. Oxygen form normal oxide, peroxides, sub and suboxides. So, while on the basis of acid-base property, we are talking about oxygen, it forms neutral oxides, amphoteric oxides, basic oxides, and acidic oxides. So that one is a brief description about oxygen. So let's see sulfur. It forms dioxides and trioxides. So the same way it forms that one, that is dioxide and trioxide. This one is a gas with a choking smell, a colorless gas with a choking smell. Selenium, on the other hand, also forms trioxide and dioxide. So that is selenium trioxide and selenium dioxide. And then we want to talk about another property. Another property we call oxo acids. So in this case, we are going to talk about sulfur, its property to form oxo acid. So these are acids with oxygen compounds in them. So on the basis of oxo acids, sulfur forms 3 basic oxo acid compounds. So we have where the suffix ends with O, U, S. For example, sulfurous acid, we have I, sulfuric acid, and then you have peroxide acid. So on the basis of oxo acids, sulfur can be categorized into 3 classifications. That is sulfurous acid series. So on the basis of oxo acids, they can be classified into series. So into this series, they can be classified based on the namings like this. So we have sulfurous acid series, sulfuric acid series, and peroxo acid series. So we will upload documents so that you can read that one on a clear note. And then finally, we want to talk about reaction of these elements with halogens. So reaction of this one with halogens. So selenium, tellurium, and sulfur react with halogens, and then they form a general reaction formula of MX6, where X represent halogen and M represent one of these elements. So we were interested in only one reaction where we were reacting sulfur with chlorine to form a compound called dihalide. So this dihalide is a false smelling liquid which produces a gas called mustard gas. So we want to finish by writing the equation of reaction of sulfur with an halogen plus an organic compound to form this gas. So we have sulfur. So this one is called dihalide. It reacts with this compound. This compound is called ethylene. So this one forms a gas called mustard gas, written as this one. This way. Yes, so this one is a very poisonous gas. Thank you. That is the end of our presentation.